Hello, hello, hello. All right, so this is video 2. We're back in example 1, and kind of the moral of the story. So why are we comparing these average rates of change in these intervals? Well, what we want to tell is we want to compare these guys. We want to compare their rate of change from the first interval to the rate of change from the second interval. And what you'll notice is that they're exactly the same. Now, when I have a rate of change that's exactly the same, I want you to look back up at the top of your notes. I want you to look at the linear function, and I want you to look at the exponential function. Now, which function do you think has a constant rate of change? And we already talked about this. And which one doesn't? So I hope you're looking at the linear function and you notice a straight line has a constant rate of change, right? It increases at a constant rate. And since these intervals have the same rate of change, this is a linear function. And I know this is a linear function because the rates of change are the same. Let's go ahead and look at the second example. Please fill this in for the second example. And we're going to go through this process. So we'll pick up pace now. So my first interval is 1, 2. I want to know what the rate of change is from 1, 2. So here's my starting point, right? My first value. So step 2, my starting point is 1, 6. This is x1, y1. Step 3, what's my ending point? Well, the interval ends at 2. So again, we're looking at x values, right? These guys are x values. So my ending point is 2, 12. That's x2, y2. And step 4, all we do is we plug in our formula. So y2 minus y1, that's a 2, I swear. I promise it's a 2. Okay, and y2 is 12 minus y1, which is 6. 12 minus 6. X2 over x1, that's the bottom part, right, in my denominator. X2 minus x1, I swear that's a 2. I promise. Okay, 2 minus 1. So 12 minus 6, that is 6, over 2 minus 1, that is 1. So my rate of change is 6 in that interval. Okay, now we're going to do the same thing for this second part. My observed interval is 3, 4. Okay, that means my interval starts at 3 and my interval ends at 4. So step 2, I have 3, 24. That's x1, y1. And I have 4, 48. That is x2. Wow, I'm really struggling with the 2's today. x2, y2. Okay, and now I just plug in these values. So step 4, calculate rate of change. So I have y2. Yep, I'm giving up on the 2's, guys. I'm going to call it 3. I'm not even going to bother here. X, I'm going to say 3 minus x1. It's supposed to be 2 though, you know that, right? Okay. So 48, right, is x2, or sorry, y2, minus 24, which is y1. So 48 minus 24 over x2, which is 4, minus x1, which is 3. So 24 minus 24 over 4 minus 3, which is 1. So this rate of change is 24. Now I want you to say to yourself, are these equal? What do the two rates of change indicate? Well, 6 and 24, those are not equal, right? That rate of change blew up, right? So this is an exponential function. Exponential function, right? Because the rate of change is not equal. All right. For this next part, I would like you to go ahead, copy down the table, copy down these points. I'd like the video to be paused, and I want you to try these ones on your own, and then we'll play and go through. Okay, so go ahead and try these two on your own. Take about, I don't know, what do you need? What, 4 minutes? Try 4 minutes on this guy. Okay, hopefully you pause the video. Step 1, my interval is 2 to 4. Step 2, my starting point, well, starts at 2, so that's 2, 16. Step 3 is my ending interval. It's 4, comma 64. I don't know why I'm trying to do brackets. And 4, I just plug in and I calculate. 64 minus 16, right? Y2 minus Y1 over 4 minus 2. So 64 minus 16, 4, 40, 48. Minus 4 over 2, which is 2. This reduces to 24. Now I'm going to go ahead and I'm going to do the same thing for this interval. It's 6 to 8. And my starting interval is 6. So that is 2, 5, 6. Wow, these are some big numbers. And 3 is 8, comma 10, 24. Whew! I'm going to need a calculator for this one. Okay, so I'm going to plug this into my calculator. 1024 minus 256, pick up sticks, over... I was waiting for that bell. 8 minus 6. So 1024 minus 256 is 768. So 768 over 2. Now if I take 768 and I divide this guy by 2, you will get 384. So 384. That's my rate of change for this interval. Now are these equal? No way, Jose. So I know this function is exponential. All right, see you, Brandon. Have a good day. I know this function is exponential because the rate of change is not equal. I'm going to go ahead. I'm going to end the video. I would like you to work on the independent practice. Once you get done with that, go ahead and access Google Classroom and complete that other assignment. Make sure you turn in the independent practice into the sub, and I will see you mañana. Bye. Schwarberg out. Like my video, subscribe, do all that.